Hello, welcome again. We are solving some conventional questions of refrigeration and air conditioning. The topic is refrigeration. Question number 30 from Civil Services Mains 2016 is a vapor compression refrigeration cycle works between pressure limits 10 bar and 3 bar. The working fluid is dry at the end of compression. There is no undercooling before expansion valve. If the refrigerant flow is 10 kilogram per minute, determine one the COP, 2 the capacity of the refrigerator. The table for properties of refrigerant is as under. At pressure 10 bar and 3 bar, various properties like saturation temperature, liquid heat, latent heat, liquid entropy and vapor entropy is given. So here as it is as the refrigerant is dry at the end of compression, so the point 2 should be on saturation line, and this is heat rejection, and this is throttling process, and this is evaporation, and 1 2 is compression. So at this line 3 2, or during heat rejection, the pressure is 10 bar, and entropy at point 2 will be corresponding to 10 bar is 5.0391. Okay, so 5 so S2 is 5.0391. So we can see that 1 2 is isentropic process. So S1 is let X be a Dyna's fraction at point 1, then S1 will be SF plus Sg minus SF into X. So S1 is 5.0391 and SF is corresponding to 3 degrees Celsius. SF is 0.5443 and Sg is 5.477. So putting these values and equating it equal to S2, we can find out Dyna's fraction, that will be 0.911, and H1 is 130, again corresponding to the 3 bar. H1 is 135.37, and this is given as latent heat, so we'll directly use it. Will not subtract it from this liquid heat. This is latent heat, or it is HFG. So that is HF plus X 1297.68, or 135.37 plus 0.911 1297.68 will be the enthalpy at 1, and enthalpy at 2 is saturated condition at 10 bar. So that is summation of these two, 298.9 plus 1166.94. So that is 1465.84, and H3 is saturated liquid enthalpy at 0.3, so that is 298.9. So H3 and H4 are equal, and COP is refrigerating effect by work done. So refrigerating effect is refrigerating effect per kg is H1 minus H4, and work done per kg is H2 minus H1. So H1 minus H4 divided by H2 minus H1. So this will be your COP. So that is 6.86, and refrigerating capacity. So this is the refrigerating effect per kg, and if you multiply it by mass flow rate of refrigerant, then it would be refrigerating capacity. So MR is 10 by 60 into 1018.65. So that is 169.775 is the refrigerating capacity.